Hello, grade 12. Let us look at this question 6. It's usually the very nice one because it takes us across even into analytical geometry. So question 6, we're given here the graphs of f of x is equal to x squared minus 2x minus 3. Coefficient of x squared is positive, suggesting our graph is concave up, okay? And our y-intercept is at minus 3, so we can see the y-intercept is on the negative x-axis, sorry, y-axis. And if we locate the position of our turning point, it's going to be minus b over 2a. This is going to be 2 over 2, which is 1. So we can see here that the turning point is to the right of the origin. So that is a perfect sketch. Obviously, the labeling gives it away. And g of x equals mx plus c. It's a straight line graph with a positive gradient. Of note is that e and p, the y-intercept is common, and that x-intercept e is common. All right, these are drawn below, okay? D and e are the x-intercepts of p. Sorry, intercept, and p is the y-intercept of f. The turning point of f is t with coordinates 1 and minus 4. Okay, already indicated. The graphs of f and g intersected p and e. Okay, that's easy. Now 6.1. So let's see what is the story here. So this is x squared minus 2x minus 3 and g of x is mx plus c. Okay, so this then tells us we can start answering 6.1. We want the range of f. We can see the graph is limited at minus 4, so it means y must be greater than minus 4, greater than and equal to minus 4. That's 1 mark. Next question, we need to calculate the coordinates of d and e. These are the x-intercepts. So we know that d and e are such that x squared minus 2x minus 3 is equal to 0. Y, these are the x-intercepts of f. Okay, great. Which implies, why did I skip? Which implies that we can factorize that. So this is x minus fact plus 1 into x minus 3. We can see therefore that x at at d, for example, is going to be minus 1, and x at e is going to be 3. We can make a conclusion therefore that point D is minus 1 is to 0, and E is the point 3 is to 0. Because we were told to calculate the coordinates. So we need to show this coordinate pair. And be careful of the notation, guys. I see a lot of complacency in some people where they write a comma between these. That's not in your curriculum, okay? Be careful. Now, let's go. What is the story there? How many marks? 3 marks. Obviously equating to 0. And then those coordinate pairs, doesn't really matter. 3 marks in the bag. This was 6.2, 6.3. We need to determine the equation of G. That's easy. For us to find the equation of G, we need the gradient. Right. So let's have a look here. First of all, we need to show that point P is going to have the coordinates 0 and minus 3. How do we know this? This is the y-intercept of f. Now for y-intercept, it implies x must be 0, and those are the coordinates. So that's easy. So we can say now the gradient of g is going to be y at e minus y at p divided by x at e minus x at p. Y at e is 0, minus y at p is minus 3, divided by x at e is 3 minus 0. So this is 1. We can say then g of x is going to be equal to x plus c. Then through this point E, any one of them actually, 3 is to 0. It is such that 0 is equal to 3 plus c. I don't know why. P is the y-intercept. We should have seen that. Damn it. Why do I like to do a back and forth? But it doesn't hurt. So that is the line G. Makes sense because the y-intercept is exactly common, and it has a positive slope, and it has an x-intercept at 3, which is that point E there. So this is correct. So how many marks is this? 2 marks. Wow. That is strange. Basically is this in the equation, because obviously there was no need to calculate this, knowing that point P was good enough. Okay. Not a big deal. So 6.4. It says write down the values of x for which f of x minus g of x is greater than 0. So that needs to be adjusted. We need to write f of x greater than, we transpose g. Now we can see we want a point where the graph of f is above the graph of g. And we can see that is happening here from this point going that side. And essentially these are not included, so let's use another color. So we can see at point E, if we go that way, the graph of f, the y values for the same x values are greater than those of g. And also from here, by the way, we're looking at the x values, so 0 here, this is 0, because the x value along the y-axis is 0. It's not included. And if we go in that direction, we will see that the graph of f is above the graph of y for the same x value. So those are the solutions. So we can say here, therefore x must be less than 0, or x must be greater than 3, because in between the graph of f is below the graph of g. Okay, great. So those are the easy 2 marks. That one needs to look out for. Alright, so they haven't really hit us with some difficult questions, have they? Now comes that one. Determine the maximum vertical distance between h and g. Wow. Now look at that, h and g. If h is basically a vertical reflection of f, because this minus f of x means is a vertical reflection. Now for what? X values between minus 2 and 3. So obviously if we do a vertical reflection, it is going to be a graph of this nature. This graph will do its own things like that. So that's how it's gonna look. Alright, great. And obviously the x-intercepts are not going to change. It's going to be 3 and 0, because remember, a vertical reflection only changes the y values. So 3 and 0 minus 2 and 0. Right, is that what we got? Yeah, no man, it's minus 1. So this is minus 1 and 0. Why don't I use another color for these? Yeah, doch. So this is minus 1 and 0. Okay, so that is essentially what's going to happen. And now the vertical distance between these two, we need to find it. We need to find it. We don't know what it is, but all we know is that this point P comes up there. Minus 3 becomes 3. That turning point becomes 4. Okay? And we just need to find that. So this is very easy. We just take the difference. So we can say this distance can be represented by, say, this line. We don't know what this distance is. This is the distance h. So let's have a look at this. So we know that h is basically the parabola. We can say minus f of x minus g of x. Right. And then what happens when we multiply the whole function by negative? It becomes minus x squared plus 2x plus 3, and we are subtracting g of x, which is basically x minus 3. So this is minus x squared plus 2x plus 3 minus x plus 3. Minus x squared plus x plus 6. Right. So this is the expression that gives us that value. So now we want this to be the maximum vertical distance. So we can say h max implies that h prime should be equal to 0. Now when we differentiate here, we get minus 2x plus 1 is equal to 0. Therefore x is going to be essentially a half. So this happens when x is a half, but now we were told to determine the maximum vertical distance. So we can say therefore our h max, maybe here it's better to say for h max. Now we are doing the determination. It's going to be minus into a half squared plus a half plus 6. Okay, they chose some easy questions to ask, honestly. Minus into 1 over 2 squared plus 1 over 2 plus 6. Okay, I'm getting 25 over 4, which is basically 6,25 units. Remember, this is the distance, so we can go on and do what we want to do. So this is equal to 6,25 units. Now this is a distance, so if one leaves out that unit of measurement, somebody is committing suicide. Okay, first of all, this is a mark to get this composite function, and to know that this needs to be equated to 0 and the actual differentiation, and finding the x value, and eventually finding the distance. Easy. So I think those 5 marks are scored as easily as that. But they can be distributed otherwise. Okay, guys, not a big deal. That was also an easy question to deal with. So 6.6 says, and can you see minus a half is already satisfying the fact that this is between 3 and minus 2. So that is very good, because outside it could be a lot greater. But now within this given domain, that's what matters here. So it's very interesting. I did not even pay attention to that. Anyway, that's fine. Let's go on, guys. We have a lot of work to do. Now, what is the story here? It says, if given k of x is equal to g of x minus n. Zasuka, kwasuka lokho. So we've got k of x is equal to g of x minus n. So what is going on here? This is a vertically shifted. So this is a vertical shift or translation of g. Okay, good. Now we are told here that determine n if k is a tangent to f. Whew. Hey. Kabe sekuyashisa njalo. What is this k, by the way? K of x is going to be x minus 3 minus n. Okay. Now that's fine. Remember, what this represents is the y-intercept as a whole. So this is the line of k. And what is its gradient? Its gradient is the coefficient of x, which is an invisible one. So if this is to be a tangent to f, that means we need to find the point of tangency. Okay? And this line has a gradient of of 1. So this means is a line parallel to this g, but that becomes a tangent to f. So that is probably the point of tangency. I'll just say point POT. That is the port. X is to y. Yeah, my colors are not really coming out nicely there. So the port has x is to y. And we need to find that point of tangency right there. Okay. So that is not a problem. We can work it out. We know the gradient. So we know that at the point of tangency, I'm going to write POT to guide my examiner so that they understand when I use the word port. Sometimes using abbreviations is bad, okay? One needs to introduce that and then use it. It is such that the first derivative of our f function is equal to the gradient of our function k, which is 1, because we can see that that gradient is 1. Then let's differentiate f. When we differentiate f, we get 2x minus 2 is equal to 1. This implies that 2x is equal to 3 Therefore, x is basically 3 over 2. So we know now that that is 3 over 2. Okay, to find the corresponding y value, we substitute this into f. So we can say f of 3 over 2 is equal to 3 over 2 squared minus 2 into 3 over 2 minus 3. What is that? So we've got 3 over 2 squared minus 2 into 3 over 2 minus 3. It doesn't make any sense, kele. A disaster, kele. Sayivele ayingozi. Did we do a correct maneuver here? Yo. Kwenzeka ntoni kongoku? Kwenzeka ntoni? What was the graph of G? Minus 3, not minus 1. Yeah, but either way, I didn't do any crime there. There was no crime committed. So, this answer doesn't make sense, man. I cannot accept it. It really doesn't make sense. My y-intercept here cannot be negative. It just can't. Oh, I drew this wrongly. Oh, goodness. So now I drew this on this reflected function. That's not the original function. Okay, I almost cried. So this is minus 15 over 4. So I can accept that now. I can see my graph was drawn wrongly. So this one we need to take it down. So we need to take it down. So this is a line parallel to that, so it's doing stuff like this. Now I understand. So this is our port right there. So let's say our port, forget that this is the turning point now. This is our port, the point of tangency. And then we found out that our x is 3 over 2, which is 1,5. That should be greater than that. It makes sense. And then the y value of our point of tangency is again minus 15 over 4. So this is a point above our turning point here. And our turning point was minus 4. Let's see, 15 divided by 4. Is basically 3,8, which is a point less than the turning point. So these points make sense. So I would accept that, therefore, my POT here is going to be 3 over 2 is to minus 15 over 4. I can accept that. Now, we need to determine the value of n if k is a tangent. So we know that this port is the line through which, is a point through which that k is passing. We can say then we know that k of x given as x minus 3 minus n through the port 3 over 2 is to minus 15 over 4. We get minus 15 over 4 equals 3 over 2 minus 3 minus n. Interesting. We take that one to the other side. It's 3 minus 15 over 4 is equal to is equal to 3 minus n. Ngathi ufuna undlalisa flip flop nje qhela kabi. Yangijwayela, and I don't know why I did that. Why did I transpose? I went sunqhela. We transpose n to the other side. Then we have 3 over 2 minus 3 plus 15 over 4. This is over 1. We can say here, therefore n must be, we look for the common denominator, which is 4. 4 divided by 2 is 2. 2 times 3 is 6. 4 divided by that is 4. 4 times 3 is minus 12. Therefore, plus 15. Let's go on. So this is minus 6 plus 15. That is 9 over 4. Ne. Yeah, maniac. So that is 9 over 4. So that is the value of n, guys. So we can leave it at that. Okay, so abakhange bafuna ukubuza amatye ne. Baniphe ama-cry nice, guys. These are good questions. They are pretty standard, to be honest. This is standard grade stuff. This is SG. Or is what would fit both standard and higher grade. They're not too difficult, so they kind of eased up a bit here. Okay, we are scoring 5 marks. So what is the story? Essentially showing our k of x is important, and to know this thing here is important. To find this x coordinate is important. Usually what matters now is going to be the substitution here in the equation of the port and the final answer. So those are the 5 marks, and that is the 18 marks of this question. So I hope you guys enjoyed it, and I will see you again next time. Goodbye.